In today's video, we want to continue to look at some differential equations and something that we've already talked about, which is separation of variables. We want to come back and kind of review this concept that we have talked about previously. So review differential equations. Differential equations is an equation where our solution is a function, and this equation has dy dx, which is y prime, minus 2y equals e to the 3x. So this is the equation that solves this differential equation. So what we want to look at today is how can we solve some of these types of differential equations, both initial value problems or for just a general solution. So if we have something like this, let's start with a simple one. Dy dx is x squared plus 1. What we're going to do in separation of variables is we're going to get all of the y's to the left side and all of the x's to the right side. So what I'm going to do here to get to that is I'm going to multiply both sides by dy dx. So I get dy is equal to x squared plus 1 dx. Now, once we get to the separated variables and we have all the x's on the one side, all the y's on the other, remember there's a 1 here, we are going to integrate both sides. So the antiderivative of 1 dy is just y, and the antiderivative of x squared is 1/3 x cubed plus x plus c. So there is our solution to our differential equation. Now that is a general solution because it has a c in it. Now, if we are given an initial condition, once we find our general solution, cubed x plus c, we then can substitute this in to try to find what our c is. This would be our particular solution based on our initial condition. And here you can see 0, 0. So my c is 4. So my solution here to this initial value differential equation is like this. So we want to understand the differences here. If it is just find a general solution and you don't give initial condition, it's okay to have your answer with C. If you have an initial condition, then you want to find the particular solution and you substitute it in to find what that C is. Let's do a little harder one. Dy dx is e to the x divided by y. So what we want to do with our separation of variables is we want to get all of our y's on one side. So I'm going to multiply by y. So I get y dy over here. I'm going to multiply by dx. So I get e to the x dx. Then we integrate both sides. The antiderivative of y is 1/2 y squared. The antiderivative of e to the x is just e to the x plus c. Now I'm going to solve for y. So this is y squared multiplied by 2, which is 2 e to the x. Still, it's plus c. And finally, to solve for y, we are going to take the square root, and we get 2 e to the x plus c. So that is our solution for this differential equation. Now, we don't have an initial condition, so it's perfectly okay to leave C in our solution. Now, many times if this was a real-life differential equation that was related to something in the real world, maybe it can't be negative, so we can get rid of the negative. Maybe it's not, so for right now, we'll just leave it at plus or minus. Let's do another one. dy dx is x squared times y minus 1. So step 1, separate the variables. If I divide by y minus 1, I get 1 divided by y minus 1 dy. Over here, I have x squared dx. Now, we need to take the antiderivative of both sides. The antiderivative of 1 over y is natural log of 1 minus y. And the antiderivative of x squared is 1/3 x cubed plus c. Now next, we need to solve for y. And if you remember, the way we do this when we have a log equation is we take it the exponential of both sides, or we write it in exponential form, however you want to think about it. And we're going to get e to the 1/3 x cubed plus c. And then finally, to solve for y, I am going to add 1. Now, you may remember when we looked at this before, we said when you add exponents, really that's the same as multiplying, right? So we could write this as e to the c times e to the 1/3 x cubed plus 1. But e to the c is just another constant. So this is just c times e to the 1/3 x cubed plus 1. So there is our solution to this differential equation. That is our general solution to that differential equation. Now, if we are given an initial condition, then we can try to find what is our c. So if I substitute in 0, I get 3c e to the 1/3 0 cubed plus 1 is 3, which anything to the 0 power is 1, so that goes to 1. So we get c plus 1 is 3. So c is equal to 2. So my particular equation here is 2e to the 1/3 x cubed plus 1. That equation solves my differential equation, and that function solves my initial value. All right, you are now ready to work on the homework over section 9.3, which is the separation of variables.